you focus on?
Well, I'm more curious. I haven't done a great deal of research myself, but I did a little bit of work looking into like user engagement in terms of engaging with new editors.
Mm-hmm.
So those sorts of topics interest me a great deal.
Very cool.
Mm-hmm.
Okay, Morten, do you want to show your slides? Because it seems you're live.
Yeah, I'll do that. Hang on a sec here. There we go.
I'm waiting for the YouTube link to kind of show that you're really live. I don't see it yet.
Is that not it in the top right corner where it says live, or is that something else?
It should be, but okay, now I see the room. Okay. Welcome everyone to the September Research Showcase. We have two presentations today. The first speaker and the first presentation is from Morten Warncke-Wang. He's a research fellow at Wikimedia Foundation, as well as a PhD candidate in group lens in University of Minnesota. He has done an extensive array of research on quality of content and task recommendations on and off Wikipedia. And today he's going to talk about fun or functional, the misalignment between content quality and popularity in Wikipedia.
Okay, thank you, Lila. So I'm Morten, and I'm here to present this work, which is a collaboration with Vivek Ranjan and our advisors, Professors Lauren Trevine and Brent Hecht. This work was published at ICWSM earlier this year. There's a link to our paper from my Wikipedia user page, and I've adapted this to focus much more on Wikipedia, whereas our paper is a little bit more general. So let's get started. Peer production communities, such as Wikipedia and OpenStreetMap, have no big brother telling you what to work on. There is no director nor no conductor who directs you to work where the audience attention is. And there are no directions. Actually, there is no map describing the landscape to you, allowing you to see where work should be done. Because you might literally be working on creating that map. So how do contributors decide what to work on? In a survey of Wikipedia contributors in 2007 noted that fun was reported to be the strongest motivator. While Lacani and Wolf surveyed open source software volunteers in 2005 and found that they wanted challenges that were neither too difficult nor too simple. But with no conductor telling you where to work, what's fun for you to work on might not be what your readers are looking at. We know that Wikipedia's readers search for important content, for instance, medical information about things such as the flu, but Wikipedia's contributors might not be writing about that. With Wikipedia's visitor numbers being counted in the hundreds of millions, and page views in billions, and a project goal of providing access to the sum of all human knowledge, there's definitely a need for quality information where your readers are. In other words, there's this possibility of misalignment between the quality of content and the popularity or the size of its readership. So here's today's agenda. We'll be through the introduction in a second, and then we'll start going through our research questions. First, we want to look at how widespread misalignment is, and then secondly, we want to measure its impact on Wikipedia's readers. Then we want to characterize misalignment to understand more about it. We'll be looking at whether certain topics are overrepresented amongst misaligned articles, and we want to know whether popularity is associated with short-term surges in demand. And lastly, I'll discuss some findings and possible solutions. And there'll be these breadcrumbs at the bottom of the slide so you can follow along and know where we're at. We seek a broad, hence our research questions, and a deep understanding of misalignment. And we start by looking at how widespread it is. And this requires defining misalignment more precisely. In our paper, we introduce a new concept, the perfect alignment hypothesis, to be our yardstick of alignment. The definition of the perfect alignment hypothesis is that the limited supply of contributor work is optimally applied such that the quality of articles perfectly matches their demand. And I've emphasized a couple of points here. First of all, that there's a limited supply of contributor work. In other words, we don't live in the world where all articles in Wikipedia are able to reach featured article status. And secondly, it's optimally applied. In other words, the correlation between quality and popularity is 1. We need some data sets to answer our research questions. So we decided to gather data from 4 large and successful editions of Wikipedia: the English, French, Russian, and Portuguese. Each of these, we gathered 4 weeks of article views to approximate a calendar month. And why did we choose these 4 language editions? They're all large and successful, and they all use a 6 or 7 class ordinal quality scale, similar to the one used in the English. And the English quality scale has been shown to have notions of information quality that are similar to traditional encyclopedias. We also looked at other language editions, such as Italian, Chinese, and others, but found that in those cases, we couldn't gather enough articles. And there are also several language editions that define a quality scale similar to the English one, but don't actually use it. Secondly, we gathered a large number of assessed articles. Here's an example from the English edition. The article about Alcatraz Island is assessed as B class, which is an upper medium level quality. And if you're unfamiliar with Wikipedia's quality scales, here's an example of the lowest quality article called a stub, which are described as too short to provide encyclopedic coverage of a subject. And here's an example of a featured articles, the best articles Wikipedia have to offer. We gathered a snapshot of these assessed articles in all 4 languages at the end of our 4-week data set. And we gathered all the assessed articles we could find, which typically numbers in either the hundreds of thousands or the millions. So how do we use this information on popularity and quality to measure misalignment under conditions of perfect alignment? If we use English Wikipedia as an example, we first start with its 7-class ordinal quality scale shown in the table, where you have stub at the lower end and feature article at the higher end. You can also see the number of articles in each of these quality classes, which reveals that Wikipedia is mostly lower quality articles, and we'll see shortly how that affects things. Under conditions of perfect alignment, the 4,353 highest quality articles would also be the 4,353 most popular articles. And similarly, the 2.2 million stubs will be the 2.2 million least popular articles. We can then create this following confusion matrix, where the rows show the real-world situation, and I have shortened the class names for brevity, and the columns are the perfect alignment condition. Currently, this confusion matrix shows perfect alignment, that all articles are neatly placed along the diagonal and everything else is 0. However, the actual situation is far from perfect. And I'll highlight some trends by first using English as an example, and then I'll expand it to the other languages. The first trend is that there overall is alignment in the system, and this is found along the diagonal as shown previously. But this happens when we measure by number of articles, because the vast majority of articles in Wikipedia are low quality and low popularity. That's where the large numbers are. The article about Barack Obama, on the other hand, is an example aligned at the opposite end of the spectrum. It's one of the most popular articles, and it's gone through peer review to become a featured article. And this trend of overall alignment is consistent across languages. 60 to 80% of the articles are in alignment, with Russian Wikipedia as an exception, perhaps because they have a lower proportion of assessed articles compared to the others. Although this is something we chose not to investigate further in this study. The second trend is that high-quality articles are misaligned. A large proportion of the featured articles are not particularly popular. They're found in the bottom row, left two columns. So, in other words, self-interest creates a lot of high-quality content on niche topics. For instance, there's this beautifully written article about the British poet Christopher Smart's asylum confinement. It contains excellent information on the subject, but has a relatively small audience. It gets about 2 views a day. The work on these feature articles is important, but from a reader's perspective, the effort is perhaps better spent elsewhere. And this trend is also consistent across languages. We see that 50 to 60% of the articles of the high-quality articles in those languages are in those 2 cells. Again, Russian is slightly different, but in this case, I'm not trying to claim that the Russian articles are top quality. Instead, there's some, and it turns out that their popularity is somewhere in the middle, so they're just outside of these 2 cells that we were looking at. And as we'll see, they have a problem with high popularity articles as well. Because the third trend is that the rightmost columns that are highlighted here, the articles that are of the highest popularity are also not of the highest quality. On English Wikipedia, only 5% of the articles that are most popular turned out to be featured articles. A couple of examples are the articles about wedding and the Vietnam War. They're rated as low or middle quality, and they average about 7,000 to 9,000 views a day, respectively. And we'll study this column later more specifically because these articles are arguably the ones the community wants to focus on. And as I mentioned, this trend of high popularity being misaligned is consistent across languages. The flip side of the 5% being that 95% are not of the highest quality. And we see that across all languages, it's on the order of 91 to 96%. A pretty huge number, in not huge number in raw numbers, but a pretty huge proportion. So we have found that misalignment exists, but how does that impact Wikipedia's readers? When measuring impact, it is important to observe that readership in Wikipedia is nonlinear. The least popular articles are several orders of magnitude less popular than the most popular ones. For example, the 2.2 million least popular articles in our English Wikipedia got 235.4 million views in 4 weeks, or about 4 views a day on average, while the 4,353 most popular articles got 635.8 million views, or about 5,000 views a day. So when we know that almost all of these most popular articles are misaligned, this suggests a potentially large impact on Wikipedia's readers. In order to answer our research question, we adapt the notion of a damaged view from Preet-Horsky et al.'s 2007 group paper and define a misaligned view as a view of an article where its quality is not in alignment with its popularity. We then define categories of misalignment. Moderate misalignment is defined as 1 class away in our confusion matrix, while strong is 2 or more. And we collapse larger distances in order to counter the bias and difference in class size mentioned previously. Otherwise, the 2 million stubs would totally dominate the results here. We also have 2 variants of misalignment: insufficient quality, where demand is higher than the current quality, to the right of the diagonal in our confusion matrix and in this line, and excessive quality, the opposite. We then count up views across categories over 4 weeks and sum up across all languages. We find that misalignment negatively affects Wikipedia, with 42.7% of all article views being in the strong insufficient quality category. And keep in mind that we define this as 2 or more classes away. In other words, this means that these articles are of significantly lower quality than the readership suggests. And I talked about Wikipedia's large audience, so in the raw count, these 42.7% are about 2 billion monthly article views. So let's examine that in a little more detail. This graph illustrates the situation. The 5 misalignment categories are on the x-axis with excessive quality to the left and insufficient quality to the right. and monthly article views are on the y-axis. And I'll highlight a couple of the findings. As previously mentioned, 42.7% of the articles are in the strong insufficient quality category, and it's about 2 billion monthly views. Some examples are the articles about email, wedding, and Vietnam War that I showed earlier. Whereas the aligned articles, which we saw account for the majority of articles in Wikipedia, only account for 22.2% of the monthly article views. Here we break down by individual language, and so we can see that English Wikipedia totally dominates. It gets an order of magnitude more views than our second language edition, which is French. And English alone has about 1.67 billion views in the strong insufficient quality category. But because of English dominance, it makes sense to instead look at proportions, where we see that the trends across languages are very similar, and similar to the first graph I showed you. Large proportions of views are misaligned in the strong insufficient quality category. So to sum up, misalignment has a huge impact on Wikipedia's readership. We were also interested in characterizing this misalignment. We want to know whether certain topics are overrepresented amongst the misaligned articles. And this can tell us something about whether there are certain topic areas that the community can focus on to battle misalignment, and also whether there are certain areas where it exerts excessive effort. To do this, we want to group articles into larger topic categories. And one candidate approach is, of course, to use Wikipedia's own categories, except they are messy. A parent category is not necessarily a broader topic category, and the category graph contains loops, so this led us to seek an alternative approach. We observed that WikiProjects already categorize articles, as seen here from the Alcatraz Island article mentioned earlier, and that these WikiProjects have fairly general topical names, such as military history, mathematics, and so on. We therefore choose to use WikiProject names as topics, and it is also important to note that while WikiProjects have been broadly studied in English Wikipedia, they have received less attention in other languages. So this part of the research only uses data from the English edition. We choose to investigate two specific areas of misaligned articles. First, the set of articles that the community should be very interested in improving, the highest popularity articles that are not of the highest quality. And we labeled this data set needs improvement, and it contains 4,135 articles. We also want to know more about where the community exerts effort, and therefore choose a set of articles that are not particularly popular but have the highest quality. And we labeled this data set spent effort, containing 2,055 articles. Working with these datasets and projects, we can adjust our focus from looking at very small things, like when using a microscope, to getting a larger overview. In our case, we can do this by limiting our dataset, restricting them either by size of the wiki project, by number of articles or number of members, or filtering by number of articles in our misaligned datasets. We chose the latter in order to filter out very specific projects, because we wanted to focus on the larger ones. And because these are variables, you can, of course, build a tool around this that allows you to manipulate the data and view it differently. Secondly, our research question asks about overrepresentations. We need to account for project size. When looking at number of articles, we have here 3 examples. WikiProject biography with 1.3 million articles, military history with about 150,000, and human-computer interaction with 167. And this is as of yesterday. As the probability that a project will have an article in our dataset strongly depends on the project size, we have to account for that. So we choose to use relative risk to measure overrepresentation, as that measures how much risk is increased or decreased from an initial level. In our case, the initial level is the risk of an article belonging to a specific project by happenstance. In other words, the proportion of articles belonging to a project overall. First, we look at the needs improvement data set. And again, those are the articles that have high popularity, but not the highest quality. In this table, we see that countries show up at the top of the chart with a huge relative risk. This is perhaps unsurprising since there's a limited number of countries in the world, and people turn to Wikipedia to read general information about them. We can also see pop culture topics such as pop and rock music here, and internet and comedy. But the list also contains some important topics such as LGBT studies. For instance, the cisgender article is very popular, but only assessed to be of start class. This is a level that is described as providing some meaningful content. Next, we look at the spent effort dataset, articles that are of the highest quality, but not particularly popular. In this table, we see arguably a sign of an English bias that has been identified in previous work by Brent Hecht and Darren Gergel. For instance, there's England and Australia here, but there's also cricket at the top of the list. In a paper studying Australian sport articles in 2013, Townsend et al. Described cricket's coverage on Wikipedia as incongruous with other illustrations or measures of its popularity. We discuss some more specific thoughts about that in our paper. But we also find one of Wikipedia's most successful WikiProjects in this list, military history, which is perhaps somewhat surprising given how large the project is, with about 150,000 articles. But on the other hand, it is also a project that displays a duality. It's overrepresented in the spent effort dataset, but it's also slightly overrepresented in the needs improvement dataset, where it had 179 articles and a relative risk of 1.16. In other words, the military history project is an example of a project making arguably inefficient choices, spending effort on articles with a small audience, at the same time not spending effort on articles with a big audience, such as the articles about NATO and the Vietnam War, which happen to be in the needs improvement dataset. So having categorized misalignment by topic, we also want to know whether popularity is associated with short-term shifts in demand, such as breaking news, because learning this can help build solutions to fix the problem. Again, we choose to examine the most popular articles in the English Wikipedia that are not already top quality. We choose to use the well-studied ARIMA time series modeling approach to forecast each day of our 4-week window, using an additional 8 weeks of data to train the model for each article. The details of this approach is in our paper. What we ended up doing was hand-coding a test set of 100 articles, and found that 50 had short-term shifts and 50 did not, and that our forecasting approach was 98% accurate, mislabeling 2 articles due to random fluctuations in demand. Across our 4,135 article dataset, a slight majority of 53.6% are stable state of high demand. In other words, they are not going anywhere soon, and they are arguably the articles the community really needs to pay attention to. A couple of examples are the articles about wedding and Vietnam War that we saw earlier. At the same time, almost half have short-term trends, breaking news articles, for instance. So the community also needs a number of ambulance chasers. But trending topics in Wikipedia is not just about ambulances. While there is a lot of death in Wikipedia's traffic reports, there are also many expected or predictable topics, such as sport events, movie releases, etc. So we've seen that misalignment exists. It has a big impact on the audience, and that some topics are overrepresented among strongly misaligned articles, and that is not just about breaking news topics. Let's round this off with a bit of discussion. Our perfect alignment hypothesis describes the ideal situation, and it's a really useful tool in our analysis. But at the same time, Wikipedia is a volunteer project. A small proportion of very prolific contributors tend to do most of the work. And if we tell them what to do, they might just get angry and leave. In other words, we need to balance self-interest with audience demand. So we might like to be somewhere in the middle of this graph. It's an illustration of the degree of misalignment as a result of the percentage of self-interest. And perhaps, somewhere in the middle is where the misalignment is at a minimum. But however, we are not 100% sure it behaves in this way. it's an interesting opportunity for future work, then I'd be happy to collaborate with somebody who would like to work on that. Question is also, how can we solve this problem? When our paper got coverage in the Wikimedia research newsletter, I participated in a fruitful discussion with the contributors. And for instance, one of the contributors mentioned the need for assistance in finding willing collaborators. Some of the popular topics are simply too large to be a solo project. So we need to support collaboration, both technically and socially. And a possible starting point is to repurpose SuggestBot, the Wikipedia article recommender, to suggest both articles and collaborators. And that's something I've been working on over the summer and will experiment with, I hope to experiment with shortly. And there are also two reasons why WikiProject might be the best approach to tackling this problem. First of all, the members are already interested in a topic, thus it somewhat serves their self-interests. And secondly, we did see some evidence of inefficient choices being made in projects. Thus, providing them with information can allow them to make more efficient choices on where to exert effort. I'd like to mention in this case James Hare's WikiProject X, as he's working on building tools based on Aaron Halfaker's ORES project, as well as working with me on SuggestBot to have it support WikiProjects. And lastly, because of this duality between stable and fast changes in demand, we need a rapid response team to tackle breaking news. In Brian Keegan's research into how breaking news was covered in 2014, he found indications that some users behave like a rapid response team already. They're central in much of the breaking news coverage, but the community should consider making a more organized effort. And with that, I'd like to wrap up by thanking the Foundation, the WikiViewStats team, and Wikipedia's contributors, my fellow researchers at GroupLens, our paper reviewers, of course, and the NSF for funding, and be happy to take some questions.
Great, thank you. Thanks, Morten. Should we start from IRC, Aaron, if you want to?
Sure. Okay. So Guillaume asks, could it be that high popularity articles may be very complex or controversial and therefore more difficult to bring to high quality status?
I think the answer to that is yes, definitely in many cases. As I mentioned, collaborators pointed out that these are complex and difficult subjects in many cases that require collaboration to be tackled. And yes, they will probably also be controversial topics as well. So you'll end up struggling with covering the subject that way. How exactly to solve those problems, I don't know. I mean, we suggest that finding collaborators for tackling some of it is one way, but how exactly to tackle the controversial topics, I'm not sure about, and I'm not sure anybody else has a great answer to that either. So.
Aaron, more questions from IRC?
Well, so I figured you might like to ask your own question, Layla. That's the only other one that I have queued up.
Okay. Okay. Cool. Maybe I'll wait. I don't know if you guys have a question.
The only other thing I had to add was something I just added at the tail end of your presentation in IRC, and I suspected that for articles that are low popularity, high quality, I suspect that for many they can be good practice to get articles to high quality because they are less subject to disruption and editorial roadblocks, basically. It's not always the case that lots of voices means lots of disruption, but I suspect that some people are attracted to that because they can have their own little space to work on this particular article by themselves or with a small team of folks. Yeah,
and I mean, I'm always kind of hesitant to point out high quality articles that are low popularity, and I don't want to define it as a problem because I think the work that's done there is important, and as you say, it can be a stepping stone towards learning how to write those kind of articles, and that's important too to figure out how do you go through the featured article peer review process successfully and so on. So yeah, there's definitely there's lots of positive things about those as well.
So my question, Morten, is about basically the definition of page view. I assume you use the old definition, right, which includes also bots and spiders?
Yeah, that is correct. In this work, we did not do any additional filtering of data. The data does not contain, as far as I know, the mobile page views, because at that point that wasn't successfully incorporated into it. I mean, being able to filter out, for instance, bots and stuff like that would to some extent improve the quality of the data. I don't know to what extent. And at the point when we did our study, this was the best data we could get a hands on. So
yeah, I just wanted to suggest that if that data is available to you, basically it would be great if you have spare time or you find it interesting, basically compare even like bot spider traffic results to like human results, as much as we are cleaning the data, to see if there are any differences. I'm more curious. Me, if you're interested, kind of.
Yeah. Definitely, and then there's also this confound that in our work we're basically assuming that a single page view is a view of the whole article, sort of, you know, and you know that you don't really necessarily know what exactly in an article somebody ended up reading and so on. So there's this. That's a part of it as well. Unfortunately, I don't think that's a problem you can really solve. But doing getting bots and spiders out of it, on the other hand, should be possible. So.
Cool. So should we? Any more questions? If not, we switch to the next speaker.
So I have a question, but I don't want to take up too much time, and it seems like it might be getting close. It's your call, Layla.
We can stay a few more minutes, so if you want to ask it, go ahead.
Okay, then I'll be quick. So I took the Vietnam War because that was one of the ones that I saw pop up as an example of something that was highly popular but not very high quality. And I ran it through the ORS article quality class predictor. And it seems to think that the article on the Vietnam War is featured article class. And so what I'm wondering is if like how much of this misalignment can we attribute to the labels that people put on articles just being out of date?
That is a very good question, and that's something that we describe in our paper as well. The fact that these assessments are, you know, they're delayed, and that's basically known that Wikipedians don't come around to reassessing articles too often. And I think the work that's done with ORS and WikiProjects X to make it more accessible to Wikipedians, that you know, a list of articles that need reassessment. That's a great part of it. And unfortunately, I haven't done studies on, you know, how large of the article body appears to need reassessment. And I think this you know, that the Vietnam War article basically looks like a feature article is kind of a good indication that there's quality work that's being done, but it isn't necessarily reflected in what people get to see, or you know, it's not necessarily pushed through the feature article process. Yeah, at some point I'll probably throw all of Wikipedia at the ORS classifier and see what we end up with, and try to get a sense of how large a proportion does appear to need reassessment.
When you're ready for that, let me know. I have that data set ready.
Awesome, I will.
Okay. Thanks, Morten.
Thanks.
Cool, thank you. Okay, so we're switching to the second talk. Our second talk is by Besnik Fetaho. He's a PhD student candidate in Leibniz, University of Hanover. He's interested in understanding how to bridge the gap between structured and unstructured data, and he focuses on information retrieval, information extraction, data mining, text mining, all the cool things that we know in this area. And today he's going to talk to us about automated news suggestions for populating Wikipedia entity pages.
So, good evening, everyone. Thank you for the introduction. So, as you said, my name is Besnik. So, I'm a PhD student at the L3S Research Center. It's part of the Leibniz University in Hanover. So, I'm going to present some work that we've done together with some colleagues here at the L3S. So it's mainly about how can we actually automate the process of suggesting news to populate or enrich the Wikipedia entity pages. I think this kind of is a nice follow-up from the previous presentation where you have like lots of stub articles, basically the long tail of entities, and also the trunk entities, the popular ones. So to give you an outline of today's talk is like, first I'm going to give you some examples, like what is actually the problem that we are trying to solve here, why is it important, and how we are actually tackling this problem, the definition and motivation, and finally go to the approach, which we kind of decompose into 2 single steps. So the first step is you have a news article, and now the task is to which entity actually do you suggest this news article. After you've done that, then you have to find where do you put it in the entity page, so which section is it. And as you will see later on, there's quite some problems finding out which section, because in many cases also the section might be missing and it needs to be added. And then this experimental setup, some evaluation, thoughts, and results and conclusions. So let's begin with some kind of examples for our problem of suggesting news automatically. Is you have here 2 natural catastrophes. So the one is Odisha cyclone, happened in 1999 in India, and it had fatalities of 10,000 people and caused a damage of $4.5 billion US. So it's a very, let's say, a big natural catastrophe. On the other hand, you have Hurricane Katrina. It happened in the New Orleans region, and it had nearly 2,000 fatalities, and it cost a lot of money, so basically 108 billion US. So why is this important as an example is that both of them, even though both of them have their own kind of pages in Wikipedia, however, the Odisha cyclone is not reported at all in the actual Odisha location in Wikipedia, so the page Odisha. And this is obviously a very, let's say, important event which happened and had quite some tragic effects, but it's not mentioned at all in the Wikipedia page. On the other hand, you have Hurricane Katrina, which has a whole section in the New Orleans entity page, and it has all the necessary details. So why is this? We can only assume that for the one, actually, Odisha, we might, all of us have to look in the map and see where it is. So most of the people don't have much information, where is this place located, and maybe we can also not, we don't have that much information. On the other hand, you have New Orleans. It's a popular location, and many people basically are willing to add this information about these natural catastrophes or any other event. So you have here a misalignment, or basically like even though all this information is like highly covered by the news media outlet, the information diffusing from news to Wikipedia is there's some discrepancy there. So we want to actually automate this process so such things do not happen. And so in more detail, so what are the entity pages that we are looking at is like most of the entities comprise of facts, statements, which usually should be supported by external references. So that's also one of the guidelines from Wikipedia. And news themselves are the second most cited source, and they are basically a very good source of information because they are authoritative. Most of the news actually go through an editorial process, and they kind of, in many cases, the facts are also valid, and also they have emerging facts. So basically, they are published on a daily basis, and so yeah, you have kind of like up-to-date information. However, on a study that we've done earlier this year, we showed that actually there is a delay between the reporting of an event in the news and when it's actually included in the entity pages. So this is, as I showed in the previous example, this can be because of the popularity or because there's not enough editors. And another problem is when you're actually trying to make this approach automatic, what happens when you don't actually find the section where you should put the entity? So for automated approaches, they need to take into account also this part of information. And why is it important to solve this problem is it's kind of obvious because Wikipedia is used in many real-world applications and serves as a backbone for search, like for Google knowledge graph, Yahoo's knowledge graph. You have knowledge bases which are constructed on a periodic manner, like DBpedia, Yago, and so on. And you have other tools, like very important ones, like entity disambiguation, where they train their algorithms to have like their dictionary of entities where they can disambiguate entities in natural text. So these are kind of the points that we want to have in mind when we're doing this work. And if you're not convinced about news, so here's a plot showing for the different types of entities, the distribution or the density of news in these specific types. Across all entity types, so on average, there is roughly like 20 to 30% of news citations, and the rest is web. However, here we have to state that not always something that is cited as a web citation in the Wikipedia entity pages, it can be also another source, but it's just a generic type. And in some cases, like films, office holders, and so on, so basically these types of entities, this news coverage is actually also over 60%. So these are have high coverage in news, and therefore also it's like one of the highest external references in the Wikipedia pages. On average, you have like roughly one-on-one mapping. So basically, one news is assigned to one entity. However, there are cases where one news article is assigned to more than one entity. Like there is this pop charts, trending charts, top 100 charts, which there was the case where we found out that one news article was assigned to 81 entities. So this was a list of top 100 charts. So what is our problem? So we have a set of news articles. They are published at a given date tk, and each news article has a title, has a headline, has the paragraphs, and named entities. So the named entities we extract through entity linking tools. In our case, we use TagMe, but it can be any other tool. And then on the other hand, we have the entity pages, which are taken at the revision date before the publication date of the news articles. And each news entity page has its section template, so basically the main sections, the categories, and the entities which are extracted through the anchors. So now the task is like, can we suggest actually a news article to an entity E? If so, where do we put this news article? So basically, this is our problem that we want to solve. Our approach is we have the news article. As I said, we do feature extraction. I will explain later on what are the features or feature types that we compute. And first of all, we need to do the disambiguation process where we know, like, okay, in this article we have these and these entities. And now we have the first task, basically, for which entity do we suggest this news article. And after we've done that, we have to find, okay, now we have the entity and we know its type. So basically, if it's Odisha, it's a location. Now we need to train some classifier which takes into account this section template and tries to put this article in the given section. So it is important to distinguish the different entity types because, let's say, a location and a politician do not have anything in common in their section template. Therefore, we cannot really learn anything meaningful if we merge all sorts of entity types, and therefore we have to keep them separated. And we use like a quite abstractive entity types like only location, politician, and so on. So we do not go very deep into the type taxonomies. And for the type taxonomy, we use the one existing from the Yago knowledge base. So let's see, for the first task, what are the news suggestion attributes that we are interested for. So the first attribute is entity salience. So what this tells us is that given a news article, an entity is salient if it's a central concept in that article. If you take the example of the article written about Nikola Tesla, you will see that there is a lot of mentions about Elon Musk, Larry Page, John B. Kennedy, and so on. But it's obvious that they are mentioned in a context that they are influenced by Nikola Tesla, and therefore the article is about Nikola Tesla and not Elon Musk or Larry Page. So how can we do this? So we model this kind of entity salience as an exponential decay function. So what this means is that we will reward an entity which appears throughout the text. We will reward an entity which appears in the top paragraphs. So basically, if it appears in the first and or like top 5 paragraphs, this will have higher weight in contrast if it appears in the end of the news article, which means that it wasn't that important for the news article. And we will weigh this entity based on a ratio with its co-occurring entity. So what we have here, this in the first part of the formula, so you have PEN, so that means how many times it appears in the paragraph, the entity, and how many paragraphs are there. So basically you normalize the score, and you have also the frequency of the entity appearing in the paragraphs, and which is basically penalized by this exponential function. So this is the first attribute that we will consider as a feature for the first task. However, there's considering the entity pages where quite quickly these can get swamped with lots of information which might be unimportant. We also consider the relative entity authority. So what this tells us is that if an entity has low authority and it co-occurs with an entity of higher authority, that means that this news is important for the entity with low authority, but not the other way around. So you have here an example of Ilyas Taban, which is a pastor in Sudan. He's involved in humanitarian activities and was awarded by the Clinton Foundation Global Citizen Award. So this is obviously an important award for this person. However, for Hillary Clinton, this is merely just one of the many meetings that she has. So therefore, if we would start to add this kind of information in her page, then this would be like very long, and probably we would lose the overview of what is really important for this entity. And so what we do here is, like, the authority we model as an a priori probability in any given corpus, but it can be also centrality measures like page rank and so on. So what we do then, we compare between two entities, we compare the authority, and if I co-occur with a higher authority entity, then I count it as a hit. Otherwise, it's not a hit, and therefore, like, I just normalize the score with all the different comparisons that I have. So basically, this is the relative entity authority, which tells that, okay, I will add something in my page only if I'm co-occurring with important entities. The next feature is novelty and redundancy. So you have this accident from the Germanwings, which happened earlier this year, and so what happens in these disasters is that people react very quickly, and there's lots of media coverage, and it gets covered instantaneously. So if you want to add, even though you might have passed all the previous filters, the salience and the entity authority, then basically what you end up is just providing redundant information. So what we do here is actually we see what is already there present in the entity page, and then we see, like, what kind of information are we bringing. So are we bringing any novel information or not? And this we do by just comparing the language model, so seeing, like, how similar the news articles that we are about to suggest is with the previously referred news articles. And if they are very close, that means they are very similar, and if they are further away, then means they are, like, very different, and therefore we are adding some novel information. So this is just a simple metric which kind of encodes this information. So here is just an example where I searched for 1 week in Google about this accident, and I got nearly 11,000 news articles. So if you would be to add all this information, then this obviously would be a problem, because we would add lots of redundant information even though they are relevant to the accident. So to sum up, for the first task is that when do we want to suggest an article to an entity page is if the entity is salient, so basically a central concept in that news article. It co-occurs with higher authority entities. The article brings novel information to the Wikipedia entity page, and the next task, which will be task number 2, is where do you actually want to put it, in which section in the entity page. And it might, as you will see now, is that in many cases you need actually to expand the entity pages with for new sections. So now we've covered the first task, and the second task is consists of two steps. So the first step is we take entities of the same type and generate a section template per entity type. So a section template for locations, for politicians, and so on. And after we've done that, we train a classifier which would try to find where does this news article fit in this section template. So here is an example of what I mean with a section template generation. So as I said, the accident with the Germanwings, so it was their first in their history. So obviously they didn't have any section talking about the accidents and incidents. But if you take entities of the same type, basically airlines like Lufthansa and so on, you will see that most of them will have a section which talks about accidents, and therefore it's highly unlikely that none of the entities of the same type will have some kind of section which we wouldn't be able to fit any news article. So we aggregate these section templates, and we cluster them based on their section text. And the advantages of this is first is that we will be able, when we find this Germanwings news accident article, we will be able to put it in the correct section, and we will be also able to canonicalize this section. So if you see, let's say, the one from the section number 2 in Lufthansa, corporate affairs and identity, and the Germanwings corporate and affairs, so they are obviously more or less the same thing. So therefore, making them as a single section makes life much easier for any automated approach to know that, okay, this is one section and not two sections. We use next means, so it's basically an adaptation of k-means clustering algorithm, which kind of finds the right number of clusters based on how homogeneous these clusters are. So now, after we've constructed these templates, so now we have to train some models which would try to find the best fit for this news article. So which section does it fit most? For this, we use like several features which go at the topic level, basically seeing like if this news article fits at the topic level with the section, if it's syntactically similar, so using NLP techniques, lexical similarity is the number of entities that appear in this section and the entity kind of similar, and other frequency-based measures like how many, what's the length of this section, what's the length of the documents, basically like standard features that you find in any kind of approach. So these are the first the two tasks that kind of guide this news suggestion problem and our approach. But how do we evaluate this this approach? So there's, one could argue then say that you could take a stream of news from any index, like let's say Google News and so on, and try to add news articles to the entity pages. However, there are several challenges with such approaches. First of all, it's invasive. So if you would want to add like anything that you find, you would have to kind of wait for a time period and see whether the community of Wikipedia editors accepts it or not, and see if it's deleted to know if it's correct suggestion or not. However, there's immediately with this, there's a problem because you have this different behavior of the editors in the long tail and the trunk entities. So if I would add some false news article which shouldn't belong in a entity in a section in a long tail entity, because there's not so many people viewing those pages, this will go unnoticed, and basically it would remain there. So it's not necessarily that it would be true. Another approach would be to crowdsource these kind of see whether it's correct a suggestion or not. However, it's very difficult to find knowledgeable workers which know information about the entity and know whether it should be there or not. So it's quite a challenging problem. So our approach was slightly different. We use what is already there in the external references of type news in Wikipedia. And by doing this, we avoid the uncertainty of judgment. So basically, we don't have to ask crowdsourcing workers, or we do not have to, let's say, question the expertise of crowd workers, because the Wikipedia entity pages has gone through many revisions, and those news articles that are there, they should be there in most cases. And we are not invasive to the entity pages. We do not add like countless number of news articles. And a nice thing is that we create a reusable test bed for similar approaches which will try to tackle the same problem. So this is our strategy to evaluate our approach. And the setup is the following. So we have from 2009 till 2014 the different snapshots of Wikipedia, and we extract all the news from the corresponding years. So we have roughly like on average 50,000 news articles per year, and they are averaged. They are referenced on average by 20,000 entities and 4,000 to 5,000 sections. So how do we test our approach? Is that we train on, let's say, in 2009 for both tasks, so task 1 and task 2, and then test on the rest and see how good we are. So basically, by doing this, we take an earlier snapshot of Wikipedia and try to predict the future of Wikipedia. So what would you add in the coming years? So we have some baselines which we compare our approach. So for the first task is a work by Dunetz and Gillick in EACL. And they try to solve the same problem of entity salience. However, this is only one feature for us. And we have also some other baselines. We basically see if the entity appears in the news title, then we say, okay, this article should go to this entity. And for the second task, we just take the maximum similarity to one of the sections. And as you will see later on, this is not a very good approach, because this is not a linear function where you would just take the maximum and then get the correct results. However, on we take another baseline, which is by just choosing the most frequent section, and this turns out to work much better. To show the results for the first task, so what is the performance of our approach is if we train on 2009 and try to predict which news should be suggested for the entities on the coming years, we achieve a very good performance. So in terms of precision, for training on 2009 and testing on the rest, we get like around 93% accuracy. And the recall is 55%. However, we are not interested. We are interested to have high precision and not high recall, because we don't want to pollute Wikipedia. If we compare it to the baseline in the red line, there you will see that we outperform there by orders of 2. So we are like much better. And if we compare like what contributed to this performance from the different feature groups or attributes from the news suggestion, is that the most is done by the salience feature. So if you see the gray curve, and it's very close to the blue curve, which takes into account all features. However, also the features of authority and novelty play a significant role when compared to the baseline. We kind of argue that the novelty feature doesn't show very high improvement here in contrast to the salience features, because in the Wikipedia news citations, there's not so many duplicates, and therefore we cannot really account for seeing, let's say, like 11,000 news articles for a single event. And across the years, the performance is very stable. So by only learning in the year 2009, we are already quite good for the first task. What is the accuracy for the second task? So here, so it's basically on the left plot you see here on the blue curve, our approach, which is averaged over all entity classes. So here, obviously, the results come from different classifiers which are trained for different entity classes, but we just average to show the performance. And in year 2009, we have roughly like above 60% accuracy. And you have to have in mind that the problem here is extremely difficult, because we have on average 10 sections per section template, and therefore it's a multi-class problem. So trying to predict with this high accuracy is quite challenging, but by taking into account all the different similarities, this seems to work quite well. And nearly in 2010, we kind of like converged to our best accuracy, and the results do not change so much, so they're above 80%. On the right plot, what you see there is basically how do these section templates contribute to expanding the entity profiles with new sections. So obviously in the beginning you will see that if we train on 2009 and try to add a news article on the sections of the entities, you will see that many sections are missing. On average, it's roughly like 40% for 2010, and this obviously drops in across the years because the entity pages gets more complete. But you can see that in 2014 it was roughly 20% on average the expansion rate of the entity. So this is a really nice feature because even though if you would be able to find, okay, this is the right entity to suggest, but where do you put it? This is obviously a problem if you do not take into account the kind of the context where the entity appears. So basically all the entity instances of the same type. So to conclude, so what we've done is decompose this process of news suggestion into two tasks, and we model and define what makes a good suggestion, which we think is the entity salience, the relative authority of the entities which an entity co-occurs, the novelty of the news article that you want to suggest, and where do you actually place it in the entity profile. And obviously as a nice result was the entity profile expansion, which was everything was validated on a very quite a reasonable size data set, like 350 news articles and 73 entity pages, and all this data is publicly available. So anybody who wants to do similar work can just go on my page and see the data there and download or contact me in Twitter and email. So yeah, I would take your question now, and yeah, thank you very much for your attention.
Cool, thank you. Aaron, do you want to start from IRC if there are any questions from IRC?
So I didn't see any questions come up on IRC. Please ping me if I missed your question. But I do have one quick. So Besnik, I think this is really interesting that you've taken on the really difficult problem of trying to figure out where to actually put a citation in an article. I wonder if it's an easier problem to figure out what statement in Wikidata a citation might be most relevant to.
I'm not sure. So you mean like basically go drill down to the actual facts in the Wikipedia? So I'm right.
Oh, so in Wikidata, facts or statements are structured things, and so there's a structured property, and you might say something about that property of an item. And so I'm wondering what you think about finding a citation that might be relevant to that statement.
So so I'm working, so not on the Wikidata, but I'm working on similar things on actually the Wikipedia. So what we are trying to find out is given a sentence and basically a citation needed where they do not have a citation, how can we find that citation, that sentence needs a new citations or any other citation, and which one is it, given let's say an index that you might have, like news articles or any other documents. Turns out that the problem is much more difficult than the one that I just presented. But yeah, it's definitely a problem which we are investigating, and I think it's quite important if you could actually support these statements rather than just try to expand the entity profiles, but you could already enrich what is already there. So yeah, I'm investigating this, and I think it's much more harder than the problem I just presented.
Gotcha, thanks.
Oh yeah, I want to ask a question that kind of was brought up by Brian Keegan in the Ryoko paper in the newsletter. I don't know if you saw that. Did you consider making this into an online tool for editors directly? So the data and everything and all the kind of approaches how we compute the features are online, and I agree it's would be much nicer to offer the tool. Definitely I will do that later at some point, but at this moment, yeah, just time is short to actually make something that other people can use it. But yeah, this is in my to-do list because what I have to provide is basically the mechanism to compute the features, and I was showing the results for some supervised model which are
random forest and SVMs, but they can be anything else. So it depends on whether you want, like, let's say, to learn faster, or you want more, let's say, stable results. But the features are kind of agnostic to these models. They work pretty well in different models. But yeah, so I have kind of to wrap up all this kind of how we compute the features, how we train the models, and make it a nice tool. So it's not, let's say, like one script, but it's actually quite some code which has to be available at some point. But yeah, that's definitely my to-do.
Besnik, I have one question for you.
Sure.
This is actually rather detailed. So I don't know, it was slide 16 or 15 when you showed the recall and precision curves?
Yeah, that's 17, I guess.
Oh, 17, okay. So I was wondering why on the left-hand side, basically precision recall plot, which I don't have it in front of me right now, one of the curves is concave and the other one is convex. I thought they should always be convex.
No. So how these are computed is basically so you get the confidence from the classifier saying, like, okay, with this confidence, I predict this instance with this class. So then you can compute what is the precision and what is the recall. So it basically depends on the features that you have. So then the confidence will vary as well. So it's not necessarily that it should be convex or concave. So basically, what it should not happen is that for lower confidence of the classifier, you start getting, let's say, better results. In most cases, you start high and then you start dropping. So as it was the case before. So it's not really that the kind of the shape of these curves is fixed, but it's just you have to have in mind that you start high and go to low, because the confidence also drops as well for the classifier.
Because for the point that is concave, you can basically imagine you can pick 2 points and toss a coin and basically connect them to each other, right? As opposed to having a concave shape. So it is true that the data may generate that, but I think in terms of precision and recall, you can probabilistically do better by just tossing a coin.
No. So the I didn't show it, but actually, so it's not, let's say, the distribution of let's say these pairs, news and entity pairs, is not even. So when you actually disambiguate the entities from the news articles, you get, let's say, around 30 entities on average. So only one of them is relevant. So if you would toss a coin, you would basically be really bad. Because it's 1 out of 30 which is relevant, so it's not like 1 out of 2. So that's why it's not actually the coin tossing problem. But so the data is extremely not extremely, but it's quite skewed towards, let's say, entities which you should not suggest the news article. So basically 1 out of 30 is relevant. So you have 29 which actually are not worthy. So it's like you don't want to suggest a news article for those other entities. So it's quite actually unbalanced data set when you do this kind of disambiguation process. But turns out that, as I showed there, basically if you consider the salience of the entity, you kind of get rid of all the non-important entities quite easily.
Okay, thank you. Cool. Any other questions? No? Okay. Let's thank the speakers and see you next month.
Thank you.